Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard. This is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi, Michael. Let's talk about sub-transactions and be very short with this. This is a super simple topic because I have super simple rule. Just don't use sub-transactions unless you're absolutely necessary. And I'm going to describe details, but not going too deep. Let's keep this episode short.
Yeah, sounds great. And also, it's Thanksgiving, so hopefully people are
right. Exactly, because
a lot of our audience are listening, spending a lot of time with their family. So happy Thanksgiving to anybody that celebrates, and hopefully you'll be thankful for a short episode.
Right. I wanted to thank you, of course, for doing this with me so long.
Oh, likewise.
Right.
It's been a pleasure. Where should we start then?
So let's start with the idea of sub-transactions very briefly. The idea is if you have complex transaction and you want to to handle some kind of failure, or like for example, a statement might fail, but you don't want to lose the previous statements already completed in the same transaction, or you want, for example, to explicitly undo some steps, right? It may be actually multiple statements you can return to previous point. So you can use sub-transactions, also called nested transactions, in some cases, although it's not very nested, but kind of, okay, it's nested. Nested transactions also, there is a SQL standard keyword, I think it's SQL standard, right? Save point.
Oh yeah, I don't know if it's standard, but I think it is because I read the Postgres docs for this and they mention one tiny part of it that's not standard compliant. And so therefore I assume everything else is.
Right. Yeah, I think it's standard. Yeah. What was that part? I also remember, but I don't remember which part.
Oh, it gets into the details, but it's around the naming of sub-transactions. So you can name them so that you can then roll back to the name. And it's if you use the same name multiple times, the standard says you should destroy previous ones, whereas the Postgres implementation allows you to roll back to one with the same name and then roll back to it the same name again, but that rolls back to the previous one with anyway. Is it probably hopefully that made some sense.
So the idea is nice, right? If you have really complex transactions and you expect that you need to roll back sometimes, you just put some save points in various places and you can return to them. And you can imagine it like there are two ways to imagine it. I'm not sure both are correct. Let's discuss it. So one is like we have some flat picture and save points and we can jump. And another is nested. And I think nested is more like it's more correct. Like although it if you look code, usually it doesn't have an indentation, right?
Mm-hmm.
It's like flat, vertical, semi-indented lines of code, save point one, save point name one, save point name two, and some statements between them. And you can roll back to previous one of previous save points. But internals are it's like nested. There is nesting there applied because when you return to some older save point, you lose the deeper, like newer, fresher save points because they are internally implemented like kind of deeper. And one of the problems we will discuss, it's related to this level of nesting or depth of this nesting, right?
Yes, and I think on the basics, I think it's worth mentioning that even if you know that you haven't used save points anywhere in your code, you could still be using sub-transactions without
exactly
this, right?
Yeah, all it can call it nested transaction. So like I think nesting is the right concept here, although again like it looks like not nested but it's nested. And I think Django they use nesting word, and Django and maybe some other ORMs will provoke you using this to use it like implicitly. So you just do something and you don't know, but you use it. Also, PLPG SQL will provoke you to use it because if you at some point, if you use a lot of PLPGSQL code, as I do, at some point you will want to have begin, except, end blocks, except when, blah, blah, blah. So just to handle some failures. And this is 100% already sub-transaction, because there is another begin block which defines the main body of the PLPGSQL function. Right, so
that's the big one, I think. So the ORMs can be using it behind the scenes without you realizing. And if you've got any exception handling in functions, whether that's functions or triggers, like you are using sub-transactions, or you might be using sub-transactions.
Right. Any exception handling, or maybe the top level exception handling is it possible, like say begin blah blah? We always have begin end block for like top level, right?
Like implicitly, no, you mean in a function?
We can put exception.
I think as soon as you're using the exception clause, you are using.
Yeah, I think so as well. But I'm just curious. Okay, but definitely, if you use additional begin, exception, end blocks inside the body of the PLPGSQL function, it's already a sub-transaction for sure. So it's a implicit sub-transaction. So what are the problems with them?
Yeah, great.
Let's be short, as we promised. The very first problem is that we have still 4-byte transaction IDs, right?
Yeah.
4-byte transaction IDs means that we have like 4.2 billion space, and we can use it only half of it, because other half is like one half of it is the past, one half of it is the future. So there is a transaction ID wraparound problem which happens after 2.1 billion transactions if freezing didn't happen, if you blocked auto vacuum, for example, with long transaction or something, or just turned it all off, but it should wake up even if you turn it on off. Okay, so if so we have 4-byte transaction IDs. And to optimize how these IDs are spent, there is also the concept of virtual transaction ID. So if you just run select or some read-only transaction, it won't increment transaction ID counter, right? So you won't waste exceed value. Also, if you use sub-transactions, a transaction with a couple of sub-transactions is already 3.
Yeah, that's the big issue, right? Well, not the big issue, but in this problem,
big issue, but in this problem, faster. You start spending these quite like not cheap seeds faster than if you didn't use sub-transactions. So, but also there are multi-seeds. It's a different topic, right? So this is not. I think it's not super big topic. I just worth understanding that we move faster if we use sub-transactions quite often.
Cool. Let's move on to problem 2.
Yeah. Second problem is this nesting level, like depth of nesting. There is a cache, and if you reach nesting level 64, I don't know who does it, but this is quite well documented in mailing list and other places. Quite well documented overflow problem.
Yeah. So we're talking about doing 64 levels of that nesting depth. I did see a blog post. Was it on the Cybertech blog, I think, by Lawrence? Was that on this? Yeah. So I think it's quite easy to demonstrate this problem in
right, and we have benchmark for it, synthetic benchmark. We did it. It was easy. So you just too many save points, and you reach the level 65. This is cache per backend, so it's like local cache, and in this case, degradation is obvious. So you don't want to go.
It's not a hard limit, right? It's just you pay a performance penalty at that point. And I've never seen this in the real world. Have you ever seen a case of this?
Well, only in synthetic tests.
Yeah. Okay. Fine. Yeah. Great.
Right. So not in production, and it's not hard limit in terms of the problems it gives, but it's hard limit. You cannot change it. I mean it's a constant in source code, so it's hard. But it's not huge. You can go there, but probably don't want to go there. So a third problem is related to multi-seeds. This additional space of transaction IDs, multi-transaction IDs, multi-exec IDs. Like actually, I see it's not very well documented. These things. For example, multi-seed wraparound also might happen. We don't see big blog posts like from Sentry or MailChimp as for regular transaction IDs, but it still can happen. So documentation doesn't have a good words like details about how to properly monitor it and so on, but I mean, it's possible. Anyway, multi-exec, it's a mechanism, it's like different space, and it's a mechanism when multiple sessions establish a lock on the same object, right? For example, like share lock, for example. For example, when you have foreign keys, you deal with multi-exec like implicitly again. So Postgres establish multiple locks on the same object, and multi-seed value is assigned. And there is a problem, like there's a very good blog post from Nelson LH, how to pronounce? You should
I
pronounce
have
it better.
no idea, but Nelson seems like a good bet for the first name. I'll link it up in the show notes, of course.
Right. This is excellent blog post from 2021. I'm not sure which company it was, but the blog post explains several problems actually as well. And it explains like there is a well-known problem. Honestly, I must admit I didn't know about that problem as well. But the blog post assumes everyone knows it. Okay, so the problem it's not related to sub-transactions, but there is a problem with select for update. So there is like performance cliff. This blog post explains it. So once I read it, I started like be very careful when recommending to use select for update to parallelize, for example, queue-like workloads. And
or
actually
select for share, right?
Select for update.
Oh, okay.
It's not related to sub-transactions. We start from there. So it says there is a performance cliff related to select for update. It explains details, blah, blah, okay. And now I understand, okay, select for update, we should be very careful with it. So, and that's why I became bigger fan of single session consumption of queue-like workloads, because usually with single session you can move very fast, because once you start using select for update you can meet this performance cliff, of course at larger scale, like you have many thousands of TPS, for example. So okay, forget about select for update. Then the post explains select for share. I maybe messed up with this. You think select for share is the known problem, and select for update is where sub-transactions come to play with. Yes. So select for share is very well known problem, as blog post explains. But then if we use select for update and sub-transactions, we have similar problems as with select for share. I'm very sorry. Yes.
No.
So yeah. So if you use select for update, for example, queue-like workloads, and you have multiple consumers and you don't want them to fight with lock acquisition, so you use select for update, and also you use sub-transactions, you might meet a similar performance cliff as for select for share. Right. So anyway, watch out. Be very careful if you use a lot of like thousands of TPS. Be careful with both select for share and select for update. This is like the explanation. Again, I'm like making mistakes here because I didn't see it myself in production. I saw it in synthetic workloads again, but not in production. That's why I already keep forgetting. What do you think about this problem particularly?
Yeah, you've made me question which way round it is, and I'm not even sure if worth rereading this if this is something that you make extensive use of at high volume and want to be aware of. But if neither of us have seen it in the real world, especially you, it feels to me like this is not the one most likely. Like we've done 3 issues already, and I think it's the fourth that's going to be most likely to actually affect people and most interesting. Yeah,
I'm not sure, because again, this post by Nelson explains if you use Django, for example, and uses nested transactions, you have save points, and then you think, oh, it's a good idea. I have parallel workers consuming, like fighting with the same rows to consume like queue-like workloads or like lock them. I'm going to use select for update, and here you have the similar performance cliff as they explained for select for share. So, but again, it happens only at under very heavy loads, like thousands of TPS.
Yeah, and one point they made in fixing it was they
For
changed.
Django, even.
Yes, for Django, was there was a parameter they could change that passed save point equals false,
Transaction atomic. Yeah.
which completely fixed the issue, right? Like it
Disable save points, exactly.
Yeah.
Yeah.
It's great that people can do that, and it's really interesting that that's not the it's not the default.
Again, with fixed problems, getting rid of sub-transactions.
And they actually, before we move on from that post, they included one more line that I really liked, which was them talking to somebody else who they considered an expert on the Postgres side, and they quoted, "Sub-transactions are basically cursed. Rip them out."
Cursed.
That was, cursed or cursed. I guess.
Now I'm how to say, I'm bringing these thoughts to people, and sometimes I see pushbacks like no, like they're still good. Well, sorry, it's not only my thought. I inherited it from this post as well. But so let me explain what we saw at GitLab.
This is problem number 4.
Problem number 4, and I saw it myself and help troubleshoot, and they had also great blog post about this, and this led to big effort to eliminate sub-transactions in GitLab code. So there is another cache which is like kind of global, not per session, and it has also a threshold 16 hard-coded in source code. There is constant 16, and when you reach 16 sub-transactions on a replica. And you have a long-running transaction, different one, some select, for example, or just somebody open transaction and sitting, not consuming seed anymore. On the primary, on all replicas, at some point you will see huge degradation and some sub-trans SLRU contention. Lightweight lock. If you check, so it looks like a huge spike in persistent activity of active sessions, and these active sessions are sitting in wait event subtrans SLRU. Of course, it happens again under heavy load, like thousands of TPS. So you won't see it if you don't have a load enough. But it's a very hard problem to overcome. So it's like, and also worth to mention, it's great that you can see it in wait event subtrans SLRU. Also very great that Amazon RDS guys documented wait events. They have best wait event documentation. Postgres itself doesn't have this level of detail for wait events, so I'm constantly learning from those documents. And also, if you have Postgres 13 or newer, there is a new system pgstat-SLRU. When we saw that GitLab, unfortunately, it was an older version. So I was thinking, so sad I'm not having this view, because it provides a lot of good counters, and you can see, okay, events of trans SLRU is popping up in there. So this helps with diagnostics. And we also had after spending some efforts, we replicated this problem in synthetic environment and discussed it. And the conclusion was we need to eliminate sub-transactions. It was, again, as I said, big effort.
I found that really interesting, by the way. I found it really interesting why reducing sub-transactions wasn't enough. And it was really a case of actually eliminating them.
Yeah. Well, sorry, I said 16, 32. Here, like 64 is for this local cache, and here 32, this limit of SLRU buffer size. So yeah, you can reduce them, but it will happen only at some extent. The problem is this long-lasting read-only transaction on the primary. It can be like you have this, and also the level of seed consumption.
Yeah.
Also, right? And if you have high TPS, the higher TPS you have, the shorter this long read-only transaction needs to be so you can hit, or your replicas hit this performance cliff. So, for example, if you have lower TPS, you can still have this problem, but you will need to wait more with this long-running transaction.
You will only hit it if, like, the query is, let's say, dozens of seconds or minutes, or maybe even longer. Whereas when I think you showed nicely in your blog post, or maybe it was the GitLab one, if you ramp that up enough, this could even be achieved within seconds. Like I think the synthetic one you were benchmarking was like 18 seconds or something, but it was quite easy to see that this could be low numbers of seconds as well, quite easily.
Yeah, this like we thought about like maybe we should just control long-running transactions on primary and be more like proactive for beating them, but seconds, right? It's like already too short.
The reason I wanted to hammer that home is I don't think most people think of 2-second queries when they're talking about long-running transactions.
Yeah, long is relative.
Yeah,
definitely
true.
And so also if you don't use replicas for read-only traffic, there's no problem here. So it doesn't happen with primary. It was a difficulty when we needed to troubleshoot it, because with single node experiment you cannot reproduce it. You need 2 nodes. You need a replica to see how it works. But again, we have a publicly available reproduction in synthetic environment, so you can play yourself and see how it hits you. There are good attempts to improve it. Also, Andrei Borodin involved. This guy is everywhere. So, like, when I have some problem, I see some effort already. He participates. So there is a effort to increase the salary buffer size and also change search algorithm there and so on. It's interesting. I hope eventually it will make it into source code. And finally, let's probably talk where probably like my approach is let's eliminate subtransactions altogether. If you aim to grow till like many thousand TPS and so on. But I think we need to eliminate it in source code of application because like we have less control on it. But sometimes I still use subtransactions, for example, when deploying some complex DDL.
Yeah.
Right. Because when you need to do something, do something, and then you need to perform some additional step, and this step might fail because you are gentle. I mean, you know you need to acquire a log, but you have low log timeout and retries. You can do this retry at higher level, but you will need to redo all the steps before it, right?
Nice.
Or you can do retry here with subtransactions. But in this case, you just...
And crucially, you want a the transaction's giving you a lot of benefits that it will roll back if it fails ultimately. So the transaction itself, the top level transaction, is really valuable. So you can't get rid of that. Like you can't do it in steps. You need to do it all or nothing.
Right. For example, you have some table, you put some data into it, and then you establish foreign key, and establishing foreign key, you need retries and so on. But you also need to make sure these retries don't last long if you don't want to keep all the logs you already acquired so far, because logs, the rule, logs are being held until the very end of transaction, rollback or commit. They cannot be freed in the middle of transaction, right? This is impossible. So you should be careful with all logs already acquired. So here we can use subtransactions, retry logic, and then you just deploy it when we have lower level of TPS, and we definitely don't have long transactions, read-only transactions or other transactions on the primary.
Great.
This is the key. Yeah. So it's interesting, and it's like story 2 years long already. 2 years old already. So, but it was super interesting to see these things. And my last words, I'm very thankful that it's implemented at Postgres, and I hope it will be improved. I mean, I'm not an enemy of subtransactions. Some people might think. I think it's a great feature, but we should be very careful under heavy loads.
Yeah, makes a lot of sense. There's a couple more super minor things that I wanted to mention before we finish, and that's the subtrans SLRU. It's in Postgres 12 and older. So I know Postgres 12 is the only older version that is still supported, but it had a different name, right? Subtrans control lock, just in case.
Right. So it was renaming happened. Mm-hmm.
Yeah, and the last one was the GitLab blog post ended on a really positive note that because the reason they were able to diagnose this with you with some help from other people internally was that Postgres's source code is well documented and that the source code's open. And this would have been a really difficult issue to diagnose on a closed source system. Or anyway, I thought that was a really nice point, that even though Postgres does have this issue, or can hit this issue at scale using save points or subtransactions in general, the fact that it's open gives it that huge benefit of people being able to diagnose this issue themselves.
Right, makes sense. Yeah. So I hope it's also just like just keep it in mind. That's it. And use other people issues already documented to improve. Yeah.
Nice one. Well, thanks everybody. Thank you, Nikolai. Thank you. Well, happy Thanksgiving. Hope you enjoy it, and
thanks.
See you next week.
Bye.